So today we start with the measure of center tendency. Okay. The measure of center tendency, you know that if we have some data, we require a value which represent the whole data, whole that data set. And data set, it means the column, the variables. So that is the central tendency. As you have seen that we select one MP, member of parliament, which represents our constituency at national level. Okay. So just like for the whole data, we require some central tendency which represents our data. If somewhere we want to discuss about it. So that is so it is required. So we have three ways to measure the center tendency of the data. Generally, first is mean. Second is median. And third one is mode. Okay. So everybody knows about the what is mean, what is median, and what is mode. And I will not go in the formula of this. We just see the concepts behind it. So in mean, you see, it is an aggregate measure basically. Okay. It is a aggregate measure. Okay. Because it involves all the value and divide by the total number of values. Okay. So it is the sum and division by the total number of elements. Sum the value of elements and the division by the total number. So it involves each and every element when we calculate the mean. Median is a partition measure. Okay. Why it is partition measure? Because first we arrange the data in ascending and descending order. And then we find out the value of middlemost term. Middlemost term. So whatever the value of that term, middlemost term, is called the median. Okay. So it is a partition measure. Third one is the mode. Mode is a frequency measure because the highest frequency term value is called the mode. Got it? Now, if you see this aggregate measure, mean is the aggregate measure. If I write something here, if I am writing here 2, 5, 9, 15, 23, 29, 32. These are the values. So you see, if we calculate the mean of this, and you see 2 is our minimum value, 2 is our minimum value, and is 32 is our maximum value of this data because I have written in ascending order. And these values are called extremes. And minimum and maximum is called extremes of the data. Got it? So if you make some change here in the extremes, either in the lower side or in the upper side or in the both sides, so the mean will change or not? If you change instead of 2, you write 3 or 4 something, or you write 1. So mean will change or not? It will change, correct? It means if we change somewhere in extreme values, the mean will change. So mean is very, very sensitive to extremes. Mean is sensitive to extremes. Understand? Mean is sensitive to extremes. But if I talk about what would be the median of this data, can someone say me the median? What is the median here? Yeah. What is the median here in this data? 15 is the median. This is our median. If I am making some change in the extremes, so median will change or not? Will median change? No, correct. So the median will not change. So median is not sensitive to extremes. Similarly, mode is also not sensitive to extremes. Why I am talking about this? Mean is sensitive to extremes, median is not sensitive to extremes. Because whenever we get some data, we got some ganks in the data, some noisiness in the data, some deficiencies in the data. There might be. The deficiencies may be duplicate rows. If there are duplicate rows in your data, then it will mislead the result. Second thing, there is missing values in the data. And third thing, outliers in the data, outliers in the data. Outliers. So this three deficiency might be with data when you get the data. The sum may be 2 and the maybe 1, maybe all deficiencies would be there. So I am talking about the outliers here. What is outlier? Can somebody explain? What is outlier? Yeah. Somebody can write on the chat box. What is outlier? So can I unmute and explain? Extreme values, it's okay, but what is?
Like in the numbers, if we are having 1 to 10, but then we have a number which is like minus 100 or plus 1000. So that's like really extremes on both sides. Then I would say that both minus 100 and thousands are outliers.
Yeah. In words, we could say the number which are very different from the remaining data, which are very much different from the other data points. So they are called outliers. Okay. So what happens whenever we get the outliers in some data, we give it some treatment and we manipulate it. And we have three ways to treat the outliers. So first is we could remove the observations which are having outliers. Second thing is we could do flooring and capping of the outliers. And third, we could use some business logic and fill the and then impute the outliers. Got it? So I am talking about the second one, which is related to our this thing, not sensitive and sensitive. How do we do this flooring and capping the outliers? So we have two conditions. One, if our data is normal, okay, it is normally distributed, then what we do, we find out the upper limit and the lower limit of the outlier. So if we talk about the upper limit of the outlier, that is mean plus 3 sigma, 3 into standard deviation. That would be the critical point above which the value is always outliers. Okay. And the lower limit is equal to x bar minus 3 sigma. Is it clear? Through this formula, we could decide the limit, upper and lower limit. In the lower limit, whatever the value is less than this lower limit would be outliers. Understand this thing? It is when the data is normal. When the distribution is skewed, it is not normal. It may be positive skewed, it may be negative skewed. Then upper limit of outlier is equal to Q3 plus 1.5 into Q3 minus Q1. It is the IQR. This one is the IQR. For lower limit, can somebody explain me the formula? What would be the for lower limit? Yeah. Can someone write? Can explain it for lower limit? What it should be? Okay. No response. So it is Q1 minus 1.5 into Q3 minus Q1. In the lower limit, we have to use Q1. Okay. Neela, have you seen it? Not Q3. Here we will use Q1. For lower limit. In the upper limit, we will use Q3. So that is the value which is greater than this outlier, then it will be the outlier limit, then it will be called outliers, and we have to adjust it. So what is flooring and capping? I will explain you. Suppose we have this data, it is normally distributed. And we have these limits for our outlier, upper limit, and this is our lower limit. Okay. Suppose it is our 60 and this one is our 18. There are some other values 70 to 80 like this. So what we do, we convert these values which are outliers now to 60. Substitute instead of 72, you will substitute 60. Instead of 80, you will substitute 60. So this is called the capping. This process is called the capping. Okay, flooring and capping. And here the value is 17 or the 15. We convert them in 18. That is called the flooring. Any doubt here now? How do we do capping and the flooring? Understand? Okay. Now, what I am telling you these all things. Okay. So I will show you. As you have, suppose you have test some hypothesis, the data is normally distributed. And you have used some parametric test over there. Okay, normally distributed. And you have used the parametric test in the hypothesis. And you got the result that was not you expected. You know? And it was just opposite of your result, because the hypothesis always be accept or reject. And then you remove the outliers from the variables. And then again you retest the hypothesis. And now you get the result what you expected. It may happen when you are doing parametric tests, which are based on the group mean. Because when you remove the outliers, when you adjust the outliers, the mean will change. And the mean will change, your hypothesis results might be changed. Is it clear? But if there is non-parametric test which are based on the group median, so it will not change if you adjust the outliers. Because median is not sensitive to extremes. Is it clear now to you? Why I am asking about these all things? Okay. Right. Now, one more thing. One more thing we have. Mean is always unique of one data. It is not, there will be no two mean of a data. Median is also unique. Only single median you will get always. But mod may be more than one, might be more than one. So it is not unique. Always not unique. Always not unique. It may be bimodal, it may be trimodal also. Got it? It is a constant we have taken. Here also the 3 sigma, here we take 1.5. So it is the constant value we have to use always for the outliers. We don't go in the deep in this, because there is some statistical algorithm and the calculation. We have to go through the differentiation and the integral calculus. Then we could find out this value. So I will not explain that here. Is it clear? So it is the fix, it is the constants. You have to take this constant always. Okay, this is the fixed value. You have to always use 1.5 here for the skewed data and the 3 for our normal data. So it was all about the measure of central tendency. Now we talk about that third, which is the measure of dispersion. Measure of dispersion. Can somebody explain me what is dispersion? What is dispersion? Yeah. Someone of you? Yeah. What do you understand through this dispersion? spreadness of the data. Actually, correct. Someone else try to say something. Yeah.
Sir, dispersion is nothing but it is the average deviation from its mean value or median central tendency. Average.
Correct. Correct. Someone else want to say something about the dispersion? Someone else? Okay, no problem. Akshay is correct. And Akshay is correct 50%. Okay. I explain you what is dispersion. There are two things in the dispersion. You have explained both things, but in different way. What I would like to say that one is the spreadness of the data. And second thing is what? It is the scatterness of the data. So there is a difference between spreadness and scatterness. Can someone explain me what is the difference between spreadness and scatterness? What is spreadness or what is scatterness? I will show you that. Okay. We have this data. And if I talk about the range of data, the range is nothing. Range is maximum minus minimum. So a range would be like this. This is the range of our data. 32 minus 2, which is 30, is the range of our data. This is called the spreadness. Spreadness means it is in total, or it is that between 2 points. Between two specific points is called the spreadness. Suppose there is an interquartile range, which is the difference between Q3 minus Q1. No, third quartile minus first quartile, the 50% data. The range of 50% data is called the interquartile range. Semi-interquartile range, if we divide it by 2, we get the 25% data where lies and in which range it lies. So that is the spreadness of data, how your data is being spread. But scatterness is a different thing. Scatterness is within the data, how each element is scattered averagely. If I want to know the scatterness of this data, that I could measure through, I have some technique. So 5 minus 2 is 3. The scatterness, the distance between these 2 points. Then here 4. Then here 6. Then here 13 minus 15, it is 8. 23 minus 15, it is 8, sorry. 29 minus 23, it is 6. And 32 minus 9, it is 3. Now we add these all and divide by the number of items. To want, not items, number of these differences what we have. 1, 2, 3, 4, 5, 6. So we add these all and divide by 6. Understand? This is a scatterness, average scatterness of the data. Understand? Average scatterness of the data. This you will not get in any book. You will get the scatterness from the deviation from mean, you will get the deviation from median, you will get the deviation from mode, which are called the mean absolute deviation. or you could get the standard deviation, but you could not get the average scatterness of the data. What is the average scatterness of the data? This is the average scatterness of the data. Understand? Any doubt now between spreadness and scatterness? We will go in some deep also. First, we see about the range. First thing we have seen that the range is there. Range is nothing. The formula of range is maximum minus minimum. Suppose I have this data. This is our data, and I will click some point on this. Okay. I click some point on this. This is my zero. Scale. Please someone mute your mic. This is our data somewhere. And I am taking out two data sets from this. And first one I am taking out this. And second one I am taking out this. Just a moment, I take this one. It is my A data set. It is my B data set. What would be the range of A data set? If we talk about the range of A, so it is 8. Correct? It is 8. It is 10 minus 2, which is 8. What would be the range of B? What would be the range of B? Same. 8. Correct. If I give the range of these two, if I give you only the range of A and the range of B, can you go to some conclusion with this range A and range B? Can you analyze something through this figure? I'm telling you the range of A is 8 and the range of B is 8. Can you go to some decision?
No, sir.
No, correct. We could not go to any point of decision. If the range are different, then we could say it is the more spread or it is the less spread data. Okay, the range is different. But if the range is same of the same data, we could not conclude anything. So we want something to conclude out of this range. So we require some coefficient, which is a relative measure, because range is a absolute measure. Absolute measure. Or we require some relative measure. So I will explain you about the relative measure. How we get the relative measure of anything. Whenever we get the coefficients of something, it is called the relative measure. As we have seen the coefficients, so many coefficients we have seen in the chemistry. We have seen in the physics also so many coefficients. Here also in the statistics, we have got so many coefficients in the correlation analysis, like the Carl-Pearson coefficient of correlation, Spearman's rank correlation, Kendall correlation coefficients. So these are all the coefficients. Coefficients is a relative measure because in the correlation we are relatively doing something between two variables. And we are measuring the relationship, degree of relationship. So that is a relative measure. So always in the correlation analysis, we could not say that I have find out the correlation. You have find out the coefficient of correlation. We could measure the coefficient of correlation. We could not measure the correlation between two. Okay, so that is the coefficient of correlation. In general language, we say we measure the correlation. It means that the coefficient of correlation. The relative measure is a coefficient. So we see about the coefficient of correlation. Coefficient of range, sorry. Which is nothing. It is the maximum minus minimum over maximum plus minimum. Is it clear? If I say that, find out the coefficient of A, coefficient of range of A. So it would be in the numerator, it would be 8, and the denominator, it would be 2 plus 10, which is 12. Or I will get here 2 by 3, which is 0.67 would be the coefficient of range of data A. And it is for A. And for B, if I measure it, then 8 over 28 plus 20, 48. So 1 by 8, 1 by 6. So it is how much it would be? 0.16. Thereabout. Is it correct?
Yes, sir.
So the coefficient of this A's data set is 0.67 and the coefficient of this data set is 0.16. If I take another data set, suppose, if I take another data set, I take a data set from here to here. So what would the coefficient? This is my C1, C data set. Okay. Then what would be the coefficient of this C? 8 over 24. 16 plus 8, 24. 1 by 3. It is 0.33. Now, watching this 3R coefficient of correlation and this data, can you conclude something? Can you say me something about this? Yeah. Okay, can you conclude, sir?
Yes, sir. Average dispersion of B is the smallest among all three, then C, and the largest average dispersion in A data set.
So can you correlate this with the data items?
Sir,
Value of the data?
sir,
Can you correlate this?
yes, sir. Sir, if the coefficient is small, that means the data values are larger.
Correct. Correct. Very correct. So the coefficient shows us if the coefficient is low, then it is the data came from the higher value. Okay. If the coefficient is higher, it shows that the data came from lower values. Data consists lower values. Understand? So if I instead of coefficient of range at it, if I tell you about the coefficient of these two data set, 0.67 and 0.16 for A and B, now you could say something. 0.67, 0.16. The range is same, 88. But the coefficients are different. Then you could conclude to some point. Now, to some extent, we could conclude that the data A is from the low value data and the data is B is high value data. Okay, understand? So this is the thing we get through this coefficient of range. Okay, suppose some company, two companies X and Y, two companies offered you the job, and the both companies just explained you, mentioned in their letter, coefficient of range of the salary of the employees. The company X written the coefficient of range of salary of their employees is 0.45 and company B shown 0.32. So which company you would prefer to join? Other scenarios are same. Company Y, correct? Is it clear to you? Now, this was all about the coefficient of range and range. Now we see the third one, which is interquartile range. Interquartile range, which is also known as IQR. Okay, it is nothing, it is only Q3 minus Q1. Everybody knows about the Q1 and Q3. What does it mean? Somebody don't know can ask to me.
Sir, I have a doubt.
Yeah.
Sir, it is always necessary if coefficient of range is high, then the data values will be low, or vice versa.
Yeah.
If coefficient of range is high, then data point consists low values.
Yeah, yeah.
Is it always true?
It is always true. Do you have some exemptions from it? Do you have some exceptional case?
But sir, here range is same in both data set A and B, 8 and 8. But
Yeah.
if range is different, right? If range is, so actually what I have learned in some books that we use the coefficients of dispersion whenever we want to compare two data sets, then we use coefficient of dispersion, right? So if you said previously, if range of both data sets 8 and 8, then we cannot conclude anything. But if range are different, right?
So then the range is sufficient to compare.
Okay.
Then there is no need to go for coefficient of range.
Okay.
Range itself says that this data is more spreaded or this is not.
Okay. Okay.
Range is itself sufficient to analyze some point.
Yes, sir.
Something. But in spite of that, if you suppose if you have a data like this, up to here you take 16 minus 2, what it would be? 14. Divided by 18, what would be the coefficient of range of this? Calculate it. 14 by 18.
0.77.
0.7. Now you compare with this. You compare with this. So always the lower values, you will get the high coefficient of range, whether the range is not same or the same.
Yes, sir.
You always get the same thing. Okay. Because it is the we in the denominator, we add the minimum, maximum and minimum. Is it clear? And the numerator, we are taking the difference only.
Okay, sir.
So you understand, try to understand if the difference is greater, difference is greater, then total would be greater, no? Or not?
Yes, sir. Total will be great.
Total will be greater. So the same thing will follow here. Okay. The interquartile range is this much, and there is a coefficient of interquartile range. I will not talk too much about it because it is just like a range. So it is Q3 minus Q1 over Q3 plus Q1. Is it clear? Okay. In the previous case, we have got the range of the salary of coefficient of range of the salary of the employees. If we talk about the interquartile range, I'm making two box plot here. And I'm making two box plot which are having the from the normal distribution. I'm making two box plot. Okay, making another box plot here. Okay, this is our box plot. Suppose the box plot, what happens? This is our minimum value. This is our maximum value. If there's some outliers, it would be in the point way. Okay, outside that. And these are the first quartile, these are the third quartile, and the median would be somewhere here, the median line. Okay, we are not talking about median, we are talking about the 3. You see, what does this represent? This box. The 50% data is here, and the 25% above and 25% below. Does it mean? Okay. Similarly, here you see, here the interquartile range is higher. Here the interquartile range is lower. Suppose I have the values like it starts from 8. And here is 92. It is 92 and 8. And here I have 38. And here is 54. Okay. Here I have 18. Okay. And here I am getting 72. So IQR of this A and this is B, we assume that. So IQR of A is 54 minus 38. So it is 16, correct? Not 16. Okay, correct, 16. And IQR of B, 72 minus 18. Okay. So there are different IQR we are getting. Okay. I have taken the median and we are talking about it, the different IQRs. So we could say that in the first data set, the 50% data lies between this small range. And here the 50% data lies between this more spreaded region, higher range, 54. So in this way, you could interpret also the IQR, coefficient of IQR. You think over it and you could interpret this thing in a proper way. Interpretation requires some thinking, some experience. You could interpret in a good way if you think over it. I will not explain each and everything. If I had in some practical problem, then I could explain in proper way. So I leave it on to you. You think over it and you try to interpret this thing. So this was all about the IQR and the coefficient of IQR. Then the next thing came, which is the fifth one, I think, or the sixth, first, second, third, fourth, fifth. That is semi-interquartile range. Or it is nothing, it is also called quartile deviation. It is Q3 minus Q1 divided by 2. The coefficient would be same because Q3 minus Q1 divided by 2 and Q3 plus Q1 divided by 2 and 2 and 2 will eliminate to each other. The coefficient would be same. So it is the interquartile range, semi-interquartile, which is the only 25% of the data will cover here. Okay. So these were the measurement of scatterness or spreadness. Can somebody tell me? Up to what we have studied, the range, interquartile range, semi-interquartile range. These are the spreadness or scatterness. Yeah. What we have studied? Scatterness or spreadness? Spreadness, correct. Achha. So these all were the spreadness between 2 points, 2 data points we were watching it. Now we see the scatterness. Something is missing, that is the average scatterness, which I explained to you. Is missing. Somebody has read about the average scatterness in statistics? Yeah. Some of you are the student of statistics, I think that. Yeah. Have you read about the average scatterness, which I explained above? No, that is not average. I explained you that here. Average scatterness, we sum this all, 3 plus 4, 7 plus 6, 13 plus 8, 21 plus 6, 27 plus 3, 30. So it is 30 divided by 1, 2, 3, 4, 5, 6. It is 5. That is different thing. That is the scatterness measurement. I don't say that that is not a scatterness. That is also the scatterness. We measure the scatterness through the central tendency. But it is the average scatterness is 5 in this data. Understand? Scatterness of this data is 5. Average scatterness of this data is 5. I am not taking from any central tendency. I am not taking the deviation from any central tendency. I am just talking about the average scatterness of the data. Understand? The difference between your mean absolute deviation, absolute mean deviation, mean absolute deviation, basically it is. Got it? So this thing is missing in the statistics. They have forgotten to involve this. They have totally ignored the average scatterness of the data. Understand? I explain, I try to do something with this. Initial data we have 2 and 2 plus 5 is 7. 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 is what? 22. 22 plus 5 is 27. Plus 5 is 32. So you get whole numbers. We have got the 7, 1, 2, 3, 4, 5, 6, 7. Here you see count the number 1, 2, 3, 4, 5, 6, 7. And what I have used as a common difference 5, which I have got average scatterness. Understand this thing? Okay. Sometimes we require this average scatterness instead of mean absolute deviation or the standard deviation. I prefer to rely on this instead of standard deviation. Okay. Now we talk about the scatterness. Average scatterness I have explained you. We will see the scatterness what we have read in the book. Because what we do, we people, I have seen that most of the people blindly faith on the books. Only whatever the journals and the research paper and the books, that is true. Beyond that, nothing is true. They think so. So if Einstein thinks in this way, or the Ramanujan thinks in this way, then they could not discover the new things for you, for us. Understand? I don't say that whatever the books you don't have to rely, you have to rely, but you have to think about it. What else may be there? Okay. Now we talk about the scatterness. I explain this scatterness first. These are the data points we have. Okay. And here in these data points, somewhere is mean, somewhere is mode, and somewhere is median. And these are what the data point x1. Sorry, I take the blue color here. Is our x1, is our x2, x3, x4, and xn up to xn. This is the xn minus 1. This way we have these all points. We want to find out the average deviation through the central tendency. In the previous case, when we were talking about the average scatterness, we use in the clustering techniques. In the average scatterness, we have seen, first we arrange the data in ascending order, and then we see the difference between two data points is formed. Then difference. That is the scatterness. That is a different scatterness. And the subsequent points, the difference between two subsequent points. In this way. Now here what we are doing, we are taking the difference between mean and x1, sorry, difference between this mean and x1, and then x2, then x3, then x4. In this way, we take the difference up to the end point. We got the end deviations here. What we do, basically, we get xi minus x bar. And some values may be positive or some values may be negative, because the value which are more than mean, they would be positive. The value which are less than mean may be negative. And when you get the deviation from actual mean, you always get the sum 0. So what we require here? We require to get the absolute value, the value which are negative, the value of deviation which are negative may convert in positive. So we have converted this value in positive, and then we take the summation of this all and then divide by n. So it is the deviation, absolute deviation. We are dividing by n. So it is the mean of absolute deviation. It is the mean of absolute deviation. So it is called mean absolute deviation. Got it? It is also written MAD. This deviation we are taking through the mean. We could also take the deviation through median, and this is represented by delta x bar. This is represented by delta ME. Similarly, we could take it from mode also. This is Z, and this is represented by delta Z. Understand this? Is there any doubt? It is the mean absolute deviation. It is showing us the scatterness through some central tendency of the data. Understand? Just a moment. Is it clear? So that is the mean absolute deviation. In this mean absolute deviation, we have three abuses here. What are the three abuses? The three demerits. First one, if you write mean absolute deviation somewhere, Matt, you say it is 65. Then one could not judge from which central tendency this deviation has been taken. If I say you the mean absolute deviation is 65, can you judge from which which central tendency I have taken this deviation? Can someone judge it? Yeah. It means until I won't say you that I have taken from this particular central tendency, you could not guess it. Okay. So first demerit was that there is no fixed measure of central tendency. There is no fixed measure of central tendency. Second thing, to convert negative into positive, it is okay in arithmetic. We could convert, we could use the absolute value, but it is not valid in algebra. It is not algebraically right to use absolute value. We could not use the absolute value algebraically. We could not apply it. Third one, it is unidirectional. It is unidirectional. What I would like to explain. You see here, whatever the value you will get through this, you will always get the positive. Can you get the negative value out of this sometimes? Yeah, someone explain. Can you get the negative mean absolute deviation? No, we could not get the mean absolute deviation negative. Understand? Then it is unidirectional. Whenever you have the deviation, if you see a pendulum which deviate, This pendulum deviate both the sides to the same distance or not. It represents the deviation and the positive side and the negative side. Okay. So deviation is always bidirectional. It is not unidirectional. So these three abysses were found in mean absolute deviation. Then they have decided to do something standardized. So they give the name standard deviation and remove these all abysses from it. In standard deviation, first thing, which was the central tendency is to be fixed. Here they have fixed mean. The standard deviation always be taken from mean, not from median or mode. Second thing, using other technique for converting the negative into positive. So if I have a -2, if I make the square of -2, I will get the positive value always of the negative, or positive will be positive always. So using square of deviations. Second thing. Third thing, taking square root. If you get the square root, you will get the positive, negative both. It is bidirectional. All the three abysses have been fixed now. And I will explain you the formula general. With the xi minus x bar, get the square of this. So it all converted in positive. Now we get the summation of this. And then I divide by n. So I'm getting the mean of the square of deviation. And at the last, I'm taking the square root of this mean. That is called the sigma standard deviation. It is the bidirectional. Is there any doubt? Yeah. Is there any doubt? Nobody is responding. Gajendra, have you got it? No doubt, Akshay one. Udit. Okay. Bhumika? Janabi? Ivan? Bidirectional is a negative and positive. I will explain you in this way. Suppose you have three sections ABC of 10th standard, and you have the average marks of the student of different section A, B, and C. This is the average marks of the students of various sections. And it is somewhere 45, it is the 62 or 65. Suppose it is the 52 in this. This is the average mark. So there is some deviation in this mark. The average deviation, standard deviation we are taking. If it's the mean absolute deviation, it would be on the one direction. On the positive value, you are getting the mean absolute deviation. But the standard deviation, you will get the negative also, positive, negative. Suppose you have 7 value of the standard deviation. So plus minus 7. So plus 7 and minus 7. This is the bidirectional. Is it clear? Subrata? Subrata? Okay. So this is the bidirectional. In the mean absolute deviation, there is only one direction, upper side, on the positive side. There is no negative side. Deviation repellent. Okay. Because statistics is science. And the science does not based on the only your assumption. And you assume that the mean absolute deviation may be in the both side, negative and positive. You assume it. It did not don't works on the assumption. It works on the concrete things. It is science as well as an art. So it is the mean absolute deviation. Now a few more things I would like to explain about the variance. Variance is nothing is the square of standard deviation, or if we talk about the coefficient of range, coefficient of standard deviation and coefficient of variance, there is no much difference. If you multiply the coefficient of standard deviation with 100, it is the coefficient of variance. Or if you don't multiply, it is the coefficient of SD. Understand? So this all we have studied here. We will discuss about the correlation later. Now we talk about R. Because the theory has been, we have covered all the theory. I think you are all satisfied with this. And very few responses I am getting out of this session. It is not as interactive as it should be. There are only few persons who are involving in this session. Like Akshay and 2 or 3 who are involved here. Most of you are not, I think that you just open your mobile and log in and you kept the mobile somewhere. You're not in the class. So I hope you all in the class. So can you write on the chat box? Yes. The persons who are available in the class. Okay, if you are there in the class. And next we see how many of you have aware about the R and R Studio and R programming. Yeah, how many of you? Ivan, correct? Okay. Bhumika, are you aware about it? R and R Studio? Udit, it is totally new for you, correct? Okay, Bhumika, it is also new for you. Harish, okay, okay. Tanushree have installed in the laptop. Neela is used before, okay, okay. Also is new. Oluwatobi also is new. Okay. Regular user, I want to learn more. Okay, Ivan Das, thanks. So some of you are not aware about the R in R Studio. So first I explain you about the programming language, because the most of you have used a few softwares like the up to now you have been using that advanced Excel or the Excel sheets. This you are using for the calculation of the mean, and these all some small activities or some advanced Excel is also there. Some of may you are using SPSS, or some of may be the SPSS and the says, maybe using. Here in the programming language, there are two way to do the things. One is the GUI, graphical user interface. Whenever you download any programming language and install it in your system, so along with that programming language, you get one thing which is called the GUI, graphical user interface. Okay, we could work with the language in terminal also. Terminal window you have, or you could work there also, but the every language provided one graphical user interface on which you could work with the language. So I will show you the graphical user interface of R first. This, are you getting my window on screen on your window? Sorry. Okay. So this is the graphical user interface. There is a R version 4.0.0. The latest version is R.0.2. Oh, sorry, 4.0.2. And if I write on this user interface something, x is equal to 5, y is equal to 7, and then I perform some operation x plus y, I will get the result to earlier. So this is the graphical user interface, but it is not as much as interactive as we fellow would like to work like analysis. Yeah, so you will write here, you will get the response here. How do you copy it? And these are so many things. So there are few IDEs developed by the programmer or the programming language from communities or some other fellows also. They provide some integrated development environment, which the development and environment automatically integrated with your GUI or with that your programming language, not with the GUI, with the programming language what you have installed, and it will give you interactive learning, and it will provide you the interactive environment of working. So that is called the IDE, Integrated Development Environment. Now I will show you one of the IDE of R, that is the R Studio, which is developed by R itself. So I will show you that IDE first. So I turn off this GUI and I do one thing. Whenever you first time open this IDE R Studio, you will get three windows, 1, 2, and 3. All the windows will blank, and this console window you will get some version 4.0.2, which is the latest version, and always they give some name to the version, and it is developed, it is being launched on the 22/6/2020. So that is the 22 June. It has been launched. It is all open source and the free of cost. And it is written here. And it is a console window. If you write something, it will work like a GUI. Yeah? It will give the response on the same window. If I write X, Y equal to say 1 and X plus Y, I'm getting 12. Okay. So this is the console window. This one is the global environment because you have assigned X the value 5. So it will show X is 5. Now it is in the global environment. Up to you turn off your R, it will be in the global window. If you save it, then next time you will get X is equal to 5 and Y is equal to 7 in your global window. If you don't save, you will want to get it, and next day you have to run it again. So it is the console, but the console, whatever you have written in the console will not save. When you turn off your R Studio, then it will go. Okay. So there is one fourth window we will open. That window is here on the left side, R script. So it is a script window. Now we have 4 windows. First window is the script window. Second window is the console window. Third window is the environment window. There is a history, connection, tutorial. I will explain you later these all things. There is a plot, help, files, packages, viewer. I will explain you these also. I will explain you terminal and jobs, everything, but later. First we see how does it work. I remove this from the global environment. So I will use this brush. So it will remove the items in my global environment. I want to remove the items from this console. Then I will use Control L. Control, then L. So I will remove the whole items from the console. And now I want to write something on my script. Now, whenever I use the script, I have to write some comment. Suppose the comment will not read by the R. It will just print whatever you have written it. It will not work on it. So that is the comment. In the most of language, we use the hash sign. And if you want to write the first class, first R class, I am writing this. I have used the hash. So if I run, I will not get anything in the console. Okay. If I select and run, then I will print it on the console, but R will not involved in the calculation and anything. Suppose if I write something like some letters without hash and I run it, I will get some error because the R is using his mind to read this statement. And he won't get anything. Right? R doesn't have FD, F, KJ. It could not recognize it. So the object FD, FKJ not found, it will say. But when I use the hash, if I use the hash and then I select and run it, then it will not give me any error because R is not using its mind to read this. It just print it. Understand? Second thing, if I write anything in the same, I am writing here. I am using enter sign and there is no difference. It is not working if I use the enter sign. So it will just like a cursor will move and it will not run the script. Whenever you have to run any syntax, this is called a syntax or the command or the line, statement line. You want to run this. Then you put the cursor somewhere on the line and then click this button. One option is this. When you click it, you will get it the global environment. And it will print also here. Okay. Another way you have to run this, you put the cursor somewhere on the line or control enter. Control plus enter. So it will be run in the same way. It is the short key. We use it. And if I ask what is x and then I control enter, I will get the value of x is 5. If I want what is y, so I will get the value of y. And now I need to perform some operation. So I will get the result in the console. So whatever you write in the script will be saved in the real time. Okay, you don't have to control S and anything there. If I, so it will, you will get there always. Okay, it will be saved on the real time. If your system incidentally, accidentally turn off, and the next time whenever you open, you will get the same script. Okay. So that is the thing. So now we see how to download these two, the R programming and R Studio, because the R programming is compulsory. Yeah? First, you have to install and download and install the R programming. Then you have to download and install the R Studio. It automatically will integrate with the R programming. So I will explain you how to download it and install it. You just write R programming download. Yeah, download R programming this way, and then you enter. So the first on the upper side, you mostly get this cran.r this project.org bin Windows. If you have the Windows operating system, if you have the other operating system, you could search for that. Here you get the download R4.0.2, which is the latest version. You click on it. Okay, so it will be downloaded in your system. After getting download, you double click, just like this is the R4.0.2 version I have 4.0.0 I have. So I just double click, it will be downloaded in my download folder or wherever. Then I double click on there or I run it. So then you have to click on the run and then follow the instructions, whatever. Okay. So the R programming will be installed in your system. Okay. Second, once you install the R programming, then you have to install the R Studio. So R Studio download for Windows. Yeah, Mac is, it is for Mac also. You could here write, go to here. Are you getting this screen? You just click here. Now you will get the Mac. Now you read the instruction and follow it. Okay. Get it? You read the instruction, then you follow it, you will get. The rstudio.com is there, and you have to choose a product if you want, or you could go down here somewhere. The RStudio desktop, it is the commercial license, it is the server free, it is the server commercial license. You have to select this one. Okay, and you click on the download, and then you will get the RStudio like this. And you open it, double click on it, and say yes, and it will and follow the instruction, you will install. And when you install it, you will get two things over there. One I would like this R. This is for our programming. This is for our studio. This ball shape, the circle shape you will get here. This is the R studio. So you can open it, or you could open the new script from here, and you could work with this. So this was all about how to download the R in our programming and R studio. And the next session tomorrow, we start the basic data types. We study the basic data types of R. You download it and install it. If you get some problems, you stuck somewhere, I think there is a WhatsApp group. You haven't got the invitation or not, or the today you get the invitation of the WhatsApp group. There, then you could ask the things if you are stuck somewhere. Okay. So in this way, we could install it. Mr. Mukesh, I think, is there or not? I just hello. Ah, sir, R is logging. Yes, so that we could calculate everything. You could do with R more than SPSS. Now we are sharing this. The Mr. Mukesh is just about to log in, and then he will share that link. Okay. Yeah, he is here now.
Hello, sir. Good morning,
Hello,
everyone.
sir. Good morning. Good morning.
So, done for today, sir?
Yes, sir.
So, how we are planning for them, like, that yesterday's session which has been missed? Are you gonna take extra classes, or are we gonna make it?
Yeah, we will cover in Sunday. I think that I will try. I will inform them on.
Or we can do, sir, half an hour extra session every day, which can also cover.
We can take, but because the today's session was little bit theoretical, so I have not taken much time.
Okay.
Tomorrow we could take more time.
Okay. So we can give extra hours every day. Let's say Friday, Saturday,
we see.
So we will cover that
Okay.
gap 2 hours. So 1 hour extra tomorrow we can give, and day after tomorrow we'll give extra 1 hour. Okay. So participants, tomorrow and day after we will have 1 hour extra session, so that we can cover all the yesterday's gap. So we can finish the workshop on time. Anyone has any questions regarding that program or study material, any other things? I'm here to answer. Extra hours is cool. Thank you. Towards study material. Study material, sir, is it ready, that study material for?
It is ready, but I will upload today.
Today, okay. So today we will be sharing the study material and video recording of the session. So Tuesday and today's things will be shared. WhatsApp group link, sir, 234. WhatsApp group link. what you can do, you just mail us. I'll share you the WhatsApp link there. Okay, sir, I have not received any statement. I have paid as well as everything. Yeah, Samratji, you will get it today because the study material link is not yet ready. So today we'll share that. Anyone else has any other questions? As I already said, that study material will be given to all the paid participants only. Those who have paid the 1,000 rupees for certificate and study material, that will be shared to them only. So if you want to get the study material, and can we pay now? Yes, you can pay now. You can pay till I think tomorrow. Tomorrow is Friday, so tomorrow is the last day to that. I think till
No, sir, we
Sunday
have
we will
started
get.
from, we have
Yeah,
started.
Saturday will be last day to get. Yes, it's a Tuesday session, so it started Tuesday. So till Saturday you can pay. Till Saturday you have a last day. Last day of payment will be till Saturday for study material and certificate. After that you will be not able to pay. So till Saturday we accept all the payments who want to get the certificate, study material, and video link of the recording of the whole session. So till then you can get it. So today you can pay if you want to do it today. As soon as you pay, you will start getting the study material link and everything. That will be much better for you to practice at your home. Yes. Any other queries, please? Okay. So we are done for today. I hope that we have answered most of your question. Anyone has any question, please mail us. We'll try to answer you there or on our WhatsApp group link. So those who have not joined the WhatsApp group link, let me share you once again. Just hold on. Just a second. Let me get there now itself. I will share you the WhatsApp link now itself. Just a second.
Flava, it is 1,000 rupees, or if you see in the dollar,
Around $14, sir.
$14.
It's very nominal fees we have kept for the operational cost. Nothing else. The fees for the I'm not in WhatsApp group. Okay, I'm sharing the WhatsApp group link. Just now I have shared. Please click on that link and you will automatically get added there. If you are using laptop, please copy this link and you can use it later on your mobile automatically. If you are a WhatsApp user, as soon as you will click on that link, you will be a member of that group. All right. And uh, as sir said that it's only 1,000 rupees for the certificate, study material, and video link. It's just operational cost. As we have already mentioned that we have waived off all the tuition fees, which is 18,000 rupees, around $240 or $250. So that is waived off. Only thing is that you have to pay the small amount, token amount, just to get the certificate, study material, and video link. And you are most welcome. If you it's optional, you don't want to pay that money also, still you can join the program. You can learn, you can make your own note. It's just because of pandemic we are helping each other, and that's how we want to grow. We want to help the world because we have taken something from the society, so we should give back. All right, all of you, thank you very much, and I really appreciate your in that presence. Let's meet tomorrow again, 10 o'clock. Till then, bye bye. Have a nice day.
Okay, thanks everyone.
Those who have paid, you will start getting it material from today.
Thanks everyone.
Thank you.